Okay, in this lesson we're just going to do some examples of simplifying exponents. Let's start with example number 1. Fairly easy here. 4 cubed. That means 4 times 4 times 4, which is 64. Number 2, 1/3 to the 4th power. That means 1/3 times 1/3 times 1/3 times 1/3. However, an easier way to do it is distribute that little exponent there to the numerator and the denominator. So this is 1 to the 4th power over 3 to the 4th power. And that is 1 over 3 to the 4th power is 81. All right, answer is 1 over 81. Number 3, excuse me, -5 to the 3rd power. Since the -5 is in parentheses, this means -5 times -5 times -5, which is a -125. Number 4, 2 over -3 to the -2 power. Okay. To make this exponent a positive exponent, I need to move the -3 to the numerator. So this is equal to 2 times -3 to the +2. You can think of this as having now a 1 in the denominator if you want. So I've actually just taken this and I have moved it up to the numerator. Notice that the sign on the exponent changes, but not the negative sign on the 3. This is 2 times a 9, which is 18. Example number 5. Two-thirds to the -4. There's a couple ways to go about simplifying this. Here's one way. I can make that negative exponent a +4 if I just flip over the fraction, 3 over 2, now to the 4th power. That's 3 to the 4th over 2 to the 4th, which is 81 over 16. This one is similar. 5/4 to the -2 power. I can make this, this is equivalent to 4/5 raised to the +2 power. That's 4 squared over 5 squared, which is 16 over 25. Number 7. (5 to the -1 plus 6 to the -1. We learned with our properties of exponents that 5 to the -1 power actually means 1 over 5 to the 1st power. 6 to the -1 means 1 over 6. And so I would just add those fractions together. Let's see, we need a common denominator. Let's do that. It'll be 30. I multiply this by 6 over 6. And this by 5 over 5. And that would be 6 over 30 plus 5 over 30, which is 11 over 30. Number 8, -3 to the 0 plus 3 to the 0. Now, since there are no parentheses around that -3, this actually means -1 times 3 to the 0 plus a 3 to the 0. We learned that anything to the 0 power is a 1. So this is a -1 times a 1 plus a 1. That is a -1 plus 1, which is 0. And so number 8 is equal to, problem 8 is equal to 0. Example number 9. Negative 3x to the 4th y cubed times 4x to the negative 2 y to the 5th. Excuse me. Okay, everything's multiplied together, so I'll just do a little rearranging at first here. I've got negative 3 times 4. I'll put those in the front. I've got an x to the 4th and an x to the negative 2. That's this one and this one. And I've got y cubed times a y to the 5th. Negative 12. Right here is where we add our exponents together, and so that is x to the 4 plus a negative 2 is a 2. And here we also add our exponents together. 3 plus 5 is 8. So my answer is negative 12 x squared y to the 8th. Number 10. 6m to the negative 4 into the 3rd over negative 3m n squared. First of all, I'll take these coefficients here, 6 over negative 3. Let's just split this up here, 6 over negative 3. I have right here m to the negative 4 over an m to the 1st power. And then on the end there, I've got an n cubed over n squared. 6 divided by negative 3 is a negative 2. Here is where we subtract our exponents. So this is actually m to the negative 4. Let me change the color on this. M to the negative 4 minus 1. And here this is n to the 3 minus 2. We're subtracting our exponents. Simplify a little bit and we have our result. Oh no, we have 2 more steps here. Negative 2, m to the negative 5, n to the 1st. But we always want to write our answer without any negative exponents, and so what I have to do is move that m to the denominator. That will make the exponent positive, and so this is a negative 2n in the numerator. Moving the m to the 5th down here makes it an m to the positive 5, and that is my result. Negative number 11, that is. Number 11. We have 5 p to the negative 2 q times 4 p to the 5th q to the negative 3 over 2 p to the negative 5 q to the positive 5. Okay, first I'll simplify the numerator. I have a 5 times a 4, so that's 20. I have a p to the negative 2 times a p to the 5th. I add those exponents together, so that'll be p to the positive 3. Q to the 1st power plus, or actually times q to the negative 3, but I do add the exponents, and so a 1 plus a negative 3 is a negative 2. The denominator, I'll just leave it as it is for the moment. Okay. Now, 20 over 2. That is a 10. P to the 3rd over p to the negative 5. This is where I subtract my exponents. So that's p to the 3 minus a negative 5. Same thing with the q's. I subtract the exponents, so that's going to be q to the negative 2 minus a 5. 10 p to the 8th power q to the negative 7. And one more step. We always write our answer with no negative exponents, and so I'm going to have to take the q and move it down to the denominator to make that q to the positive 7. So my result is going to be 10 p to the 8th in the numerator. Move the q downstairs. It's now q to the positive 7, and that is my answer. Number 12. X to the negative 2, y to the negative 4, over x to the negative 4, y to the negative 2. Okay, there's my x's. I'm supposed to subtract my exponents in a situation like this. So that should be x to the negative 2 minus a negative 4. I'm going to do the same thing with the y's. I have to subtract the exponent. So this is y to the negative 4 minus a negative 2. Simplifying. This right here adds up to a positive 2, so we got an x to the positive 2. That exponent is a negative 2. And my last step is to write that answer without any negative exponents. So I move the y to the denominator, x squared over y squared. Solved, simplified. Number 13. Okay, I have 3 raised to the negative 4, and all that's raised to the second power. So we learned in our properties of exponents that when we have an exponent to raise to another exponent, that is where we multiply. And so this should be 3 to the negative 8 power, which if you write that as a positive exponent, I have to flip the 3 over. So it's 1 over 3 to the positive 8. And you could raise 3 to the 8th power, but that's a pretty large number, so I'll just leave my result like that. 1 over 3 to the 8th power. Number 14, which I can squeeze in here. It's rather short. X to the negative 4 to the negative 2. That is where I multiply my exponents together. So that is x to the positive 8. Negative 4 times the negative 2 is a positive 8. And that's all you can really do with that one. Number 15. X, y to the negative 3 raised to the negative 2. Now, first of all, that x in there is x to the first power. Everything in the parentheses has to be raised to the negative 2 power. So this negative 2 is, in a sense, distributed here and here. And remember, in a situation like this, we multiply those exponents together. So this is x to the 1 times a negative 2, which is a negative 2. And then we have negative 3 times a negative 2, which is a positive 6. Move the x to the denominator. And so this is now y to the 6 over an x to the positive 2. And that is our result. Number 16. Z to the negative 3 to the third times a z to the negative 6. Once again, we have an exponent to an exponent, so I multiply those. That will be z to the negative 9 times a z to the negative 6. Now, in a situation like this, we add our exponents together, so that's z to the negative 9 plus the negative 6, which turns out to be z to the negative 15th. We want to write that as a positive exponent, so I flip over the z, and that is 1 over z to the positive 15. Done. 17. Five m to the negative 3, quantity squared, m to the 4th to the negative 3. Everything in this set of parentheses has to be squared. So the 5 has to be squared, and the m to the negative 3 has to be squared. So this will give me 5 squared, which is 25. And we have right here m to the negative 3 times a 2 is negative 6. And then the other set of parentheses here, I multiply those exponents as well. That's m to the negative, let me change the color, m to the negative 12. 25 m to the, adding my exponents, negative 6 plus a negative 12 would be 25 m to the negative 18. But you want that to be a positive exponent, so I must move the m to the denominator. The 25 stays in the numerator. 25 over m to the 18th power. Number 18. 3r, quantity squared, r to the 4th, over r to the negative 2, r to the negative 3, times quantity r to the negative 3 raised to the negative 2. That's a very big problem. Okay. Let's start right here. 3 squared and r squared. So that right there is going to be a 9r squared. There's my r to the 4th. I'll put it right there. I'll leave the denominator alone. Over here, 9 to the negative 2. And distribute it here as well. Multiply those exponents. And so that is r to the positive 6. You can put a 1 under there if you want. Simplifying now. I have a 9 to the 1st here and a 9 to the negative 2 there. I add those exponents together, so that's 9 to the 1 plus negative 2. I have an r squared, an r to the 4th, and an r to the 6th. I add all those exponents up, and so that will be r to the 2 plus 4 plus 6, which is going to be 12 in a minute here. Down here, I add those exponents, so that's going to be r to the negative 2 plus negative 3. So I now have 9 to the negative 1, r to the 12th over r to the negative 5. Nine to the negative 1 is 1/9. And here we subtract our exponents. So that is 12 minus a negative 5, which is r to the 17th power. And so my answer should be r to the 17th in the numerator. And that 9, since it's a 1/9, that 9 will be in the denominator like that. And there's my answer. 3 more to go. Number 19. 5z to the negative 3 over z to the negative 1 times 5 over z squared. First thing I'll do is multiply these together. So I've got a 5 times a 5, which is 25, z to the negative 3. In the denominator, I have a z to the negative 1 times a z to the negative, or z to the positive 2. So I add those exponents together. That's going to be z to the negative 1 plus a 2. 25 z to the negative 3 over z to the 1st. This is where we subtract our exponents. And so this is now 25z to the negative 3 minus a 1. That's 25z to the negative 4 power. Then we have to move this z to the denominator to make it a positive exponent. And my answer is 25z over z to the 4th. Done. Number 20. Six m to the negative 4 over m to the negative 9 to the negative 1 m to the negative 2 over 16. Okay, there's a few ways to go about simplifying this. What I will do first is distribute this exponent to everything in the parentheses. So this is 6 to the negative 1. That's going to be m to the positive 4. You multiply your exponents, and then likewise down there. So this becomes 6 to the negative 1, m to the positive 4 over m to the positive 9. And that's times m to the negative 2 over 16. Okay, there's various other ways to do this. This is one of them. I'm going to multiply everything together now. 6 to the negative 1 times, adding those exponents up, m to the 4 plus negative 2 over, in the denominator I have a 16 and an m to the 9th. 6 to the negative 1 times m to the 2 over 16 m to the 9th. Excuse me. Okay, now to make that 6 to the negative 1 to have a positive exponent, I have to move this to the denominator. And so this becomes now m squared over 6 to the 1st times 16 m to the 9th. And 6 times 16 is 96. So this is actually it's equivalent to 1 over 96, and then I got an m squared over m to the 9th here. Subtract those exponents, and we will end up with our result, which will be 1 over 96 times, that'll be a 1 over m to the 7th. Put that all together, 1 over 96 m to the 7th power. Done. And last one, number 21. Three r to the 5th over 5r to the negative 3, all raised to the negative 2 power. 9r to the negative 1 over 2r to the negative 5, all raised to the 3rd power. I'm going to distribute those exponents first. So this will be 3 to the negative 2 multiply those exponents there and there, and so that will be, oh, and the 5. Got to go to that 5 as well. So this will be 3 to the negative 2, r to the negative 10. This is 5 to the negative 2, and this is r to the positive 6. Multiply my exponents. Same thing over here. That 3 goes here, and here, and there, and there. So that will be 9 to the 3rd, r to the negative 3, 2 to the 3rd, and r to the negative 15. Okay, let's combine some things now. 3 to the negative 2 and 9 cubed, let's put those together, like that. R to the 10th times r to the negative 3, I add the exponents, so that is going to be r to the negative 13. For the denominator, I have 5 to the negative 2, 2 to the 3rd, r to the 6, and an r to the negative 15th, add those exponents and you'll get an r to the negative 9. Now I want this exponent to be positive, so I will move the 3 to the denominator. I want this exponent to be positive, so I'll move the 5 to the numerator. The 9 and the 2's will stay there because they already have positive exponents. This becomes 5 to the positive 2, 9 cubed. Down here I got 3 to the positive 2 now, and then 2 cubed. And this, with the r's here, I subtract my exponents, so that is actually going to be 9 to the negative 13 minus a negative 9. R to the negative 13 minus a negative 9. So now we got, let's see here, we got a 25. 9 cubed is 9 times 9 times 9. I can simplify a little bit here. 3 squared is a 9. 2 cubed is 8. I can cancel one of those 9s there like that. And I have r to the negative 4th power. If I multiply all this together, I get 2025 over 8. The r to the negative 4 is 1 over r to the positive 4. And we put it all together. And our answer is 2025 over 8 r to the 4th. And there you go. That was a big problem. And there's 21 examples of simplifying exponents.